This week we will learn how to solve second order non-homogeneous differential equations. In particular, we will learn the method of undetermined coefficients. So let's recall that a second order differential equations y double prime plus px y prime plus qx y is equal to r of x. So this is a linear differential equation and it is called homogeneous if this r of x is equal to 0, and if r of x is not equal to 0, it is called non-homogeneous differential equations. And for non-homogeneous differential equations, so how we find the general solution? We need two solutions, complementary solution and particular solution. What is a complementary solution? So complementary solution is the solution of the corresponding homogeneous part. So we have this non-homogeneous equation. So when it is equal to 0, we have the corresponding homogeneous part, and the solution of this homogeneous part is called complementary solution, and we denote it by YC. And any solution of this non-homogeneous equations containing no arbitrary constants, so we know all the values of the constants, then if we have such a solution, it is called a particular solution, and we denote it by Yp. Then how we write the general solution? The general solution of the non-homogeneous differential equation is Y general is equal to Y complementary plus Y particular solutions. Great, and as I said, we will learn the method of undetermined coefficients. So to understand this method, we need lots of examples. Okay, so for this lecture, we will start with an example. Okay, let's find the general solution of this second order linear non-homogeneous differential equations. So y double prime minus y prime minus 2y is equal to, let's say, 8 e to the power 3x. So we know that to find the general solution, so as we said, general solution is y complementary plus y particular. So we need to find complementary solution y complementary, and we need to find a particular solution y particular. So we will do that. Finding the complementary, y complementary is the solution of the corresponding homogeneous part. So y complementary, so this is the solution of the corresponding homogeneous equation. What is the corresponding homogeneous equation? So we write the equation y double prime minus 2y. Instead of it is equal to 8 e to the power 3x, so we want the homogeneous part, so which is equal to 0. Okay, so this is a homogeneous with constant coefficients. With constant coefficients. And we learned how to solve last week, so we need to find the characteristic equation. So let's say with characteristic equation, what is the characteristic equation? It is lambda square minus lambda minus 2 is equal to 0. Okay, let's so write this one as plus 1 minus 2. So we can write lambda plus 1, lambda minus 2 is equal to 0. Then, so what are the roots of the characteristic equation? We have two distinct roots, right? Two distinct roots, and in this case we know the solution is c1 e to the power lambda 1x plus c2 e to the power lambda 2x. So in this case, okay, I will write it a little bit below. in this case we have e to the power minus x plus c2 e to the power 2x is the complementary solution. Great. So we need to find the particular solution. So to find the particular solution, we always work with this r of x. So we always work with this r of x is equal to 8 times e to the power 3x. So okay, let me write it now. Now we will find particular solution. So to find it, we always check. So to find a particular solution, we always check this r of x. So in this case, we set r of x is equal to 8 times e to the power 3x, and by looking at this, we need to guess what can particular solution be. So we will guess that. So guess, our first guess is okay, we check e to the power e of x 3. We have e to the power 3x, right? So let's forget about 8, and we check that if it is a part of the complementary solution of the complementary solution. So what the complementary solution was c1 e to the power minus x plus c2 e to the power 2 of x, and it does not contain e to the power 3 of x. So we can guess that. So guess that y particular solution is of the form a times e to the power 3x, since it is not a part of the complementary solution. So since it is not maybe contained in y complementary, in the complementary solutions. So we will, as I said, we will do lots of examples. So if it is in the y complementary, if it is in the y complementary, or it is a part of the complementary solution, so we will do something else. So this guess will not work, but in this case, so it will work. This is the easiest case when the r of x is not contained in the complementary solutions. So we need to find a, because particular solutions do not contain arbitrary constants. So maybe I should write this. So we need to find a since y particular does not contain arbitrary constants. So a is an arbitrary constant. Yp does not contain arbitrary constants. But we can find it by substituting it in the equation. We say what particular solutions, right? So it is a solution. So to find to find a, substitute a times e to the power 3x into the equation, into the given equation. So what was the given equation? So it was y double prime minus y prime minus 2y is equal to 8 e to the power 3x. So okay, let's substitute it and find the so let's take the first derivative. Then the first derivative is a times 3e to the power 3x. So this is 3a e to the power 3x. What about the second derivative? So it is 9a times e to the power 3x. Now we will substitute y prime minus 2yp is equal to 8 e to the power 3x. So 9a e to the power 3x minus 3a e to the power 3x minus 2a e to the power 3x is equal to 8 e to the power 3x. So if we add things, so minus 3 minus 2, it is minus 5. 9a minus 5a, it is 4a is equal to then we find that, so here we find that a is equal to 2, right? Then y particular is, so it is 2 times e to the power 3x. So you see it doesn't contain any arbitrary constant, so we know what is the constant, so it must be 2, right? 2 e to the power 3x. Then we know that the general solution is y complementary plus y particular. What was the complementary solution? So this was our complementary solution, and this was our particular solution. Okay, what is the general solution? It is c1 e to the power minus x plus c2 e to the power 2x plus particular solution. So this is our general solution. Great. So we always, to find the particular solution, we always check the r of x. Okay, let me do another example so that we will understand. So, okay, let's do another example. Find the general solution of y double prime plus 2y prime plus y is equal to 2e to the power minus x. Okay, so we need to find y complementary and y particular solution. Okay, let's first find y complementary. So this is the complementary solution. So this is the solution of the corresponding homogeneous part. What is the corresponding homogeneous part? It is 2y prime plus y is equal to 0. So we take the equation and make it equal to 0. Okay, what is the characteristic equation? In this case, it is lambda square plus 2 lambda plus 1 is equal to 0. So here 1 times 1, so this is actually lambda plus 1 square, right, is equal to 0. So we have lambda 1 is equal to lambda 2 is equal to minus 1. So we have repeated roots. And in this case, how we write the general solution? Y complementary is so general solution of the homogeneous part. So it is c1 e to the power minus x plus c2 x times e to the power minus x. So if you remember, this was y1 is equal to minus x and y2. So we find it using reduction of order, right? We cannot take the same as y1, but we find it using reduction of order, and we find y2, the linearly independent other solution, to be x times e to the power minus x. Okay, so this is our complementary solution. Then we need to find a particular solution. So to find yp particular solution, we always check r of x, and in this case, what is r of x? So here it is 2 times e to the power minus x, right? But if you look at it, r of x, so the given r of x, then it is contained in the complementary solution, right? So I see it there. So y complementary c1 e to the power minus 2x. So in the last example, we guessed that it was going to be a times e to the power 3x. Do you remember? So in the last example, but it was not a part of the complementary solution. But this time, so that kind of guess will not work. So if we guess, guess y particular is a times e to the power a times e to the power minus x. So my claim is, so this will not work. So this will not work. So since it is contained in y complementary, so it is minus x plus c2 e to the x times e to the power minus x. Okay, second guess. So now second guess. Okay, let's take multiply with x times e to the power minus x. So this will not work again because it is also contained in y complementary. But our third guess, so this time it will, so let's multiply by one more time. Okay, let's multiply with one more time. Ax squared e to the power minus x. So this time it will work since it is not contained in y complementary. Okay, let's do this. So if we assume y particular is x squared e to the power minus x, okay, let's take the first derivative. So we need to take it by using the product rule, right? So u prime v product rule u prime v plus u v prime, the derivative of the product. So we have a times 2x e to the power minus x plus ax squared times the derivative of e to the power minus ex, so it is minus ex, and we need to take the second derivative. Again, the product rule. The derivative of 2x is 2a e to the power minus 2x plus 2ax times the derivative of e to the power minus 2x plus, okay, 2ax minus e to the power minus 2x plus ax squared times the derivative of minus e to the power 2x minus plus e to the power minus 2x. Okay, we can write this one in a nice way. So, okay, this is 2a minus 2x minus, so we have minus 4ax e to the power minus 2x plus ax squared e to the power minus 2x. Now to find a, substitute y particular prime and y particular double prime into the given equation. What was our given equation? Okay, let me remember. So it was y double prime plus 2y prime plus y is equal to 2 e to the power minus x. So let's substitute and we will do cancellations. Y double prime, so I write it y double prime, and I hope I will not do any errors. So 2 times y prime, yp prime, 2ax e to the power minus x write minus ax squared e to the power minus x plus yp a x squared e to the power minus x, and this is equal to 2 e to the power minus x. Okay, let's do cancellations. Okay, if you cancel these ones, okay, let me see. So I have ax squared, and minus 2ax squared, so these will cancel. So I have 2 here, and then 2a e to the power minus 4a ax 2 times 2. These will also cancel. You see, this one and this one also will cancel. So I have 2a e to the power minus x is equal to 2 e to the power minus x, and from here we see that a is equal to 1. Then what is y particular? Y particular was ax squared e to the power minus x. So this is x squared e to the power minus x. Then what is the general solution? Y general is y complementary plus y particular. Then our general solution is, okay, the complementary. This one, let me write it, c1 e to the power minus x plus t2x minus x plus y particular plus x squared e to the power minus x is the general solution.